Welcome back to Math 109 Plane Trigonometry. In this video we're going to take a look at how to solve a right triangle when we're given an angle and a side. So in this example we're going to take our triangle and we're generally going to use a triangle A, B, C with side lengths A, B, and C opposite of their respective angles. Now C, whenever we're working with right triangles, is always going to be a right angle. So in this case, I'm going to give you that little c is equal to 12.7 inches. And then capital A, so that angle, is equal to 34.5 degrees. So now we want to solve for the angle B and the side lengths A and B. Now, due to the fact that we could get some round-off error, maybe miscalculate something, and then that'll propagate through the entire problem, we always want to work with what's given to us as much as possible. So one thing that we know is that the sine of angle A is equal to the opposite over the hypotenuse. In this case, that is A over C. Well, we know what capital A and lowercase c are, so we can say the sine of 34.5 degrees is equal to A over 12.7. We'll worry about the units later. So we can multiply both sides by 12.7. So 12.7 times the sine of 34.5 degrees is equal to A. And at this point, we'll just punch it into the calculator. And I get that that equals 7.19. We're going to round this to this point. If you do any work in the sciences, you'll work with significant digits. For the most part in this class, I will tell you where to round your answer to. So we get that A is equal to 7.19. Now, a couple ways at this point that I could solve for B. I could use the Pythagorean theorem, but I could have a round-off error that's going to throw me off, or I could have just me miscalculating the number, and it'll throw me off. So I'm not going to use the Pythagorean theorem here. Instead, I'm going to use the fact that we know that the cosine of A is equal to the adjacent over the hypotenuse, which is B over C. And we can just go right back to where we were before. We know what lowercase c is, we know what capital A is. So we get the cosine of 34.5 degrees is equal to B over 12.7. And we can move the 12.7 to the left-hand side. So multiply both sides by 12.7. And then we can punch this into the calculator. And for this one, I get 10.5. And both of these are in inches. Then the final thing we have is that angle. So we'll recall that we have a right angle at angle C, a 34.5 degree angle at angle B, A, and we know A plus B plus C is equal to 180. Now when we're solving right triangles, C is always going to be 90, so if I subtract that off, in working with right triangles, we always get A plus B is equal to 90. Well, we know that A is 34.5. And I will go ahead and leave off the degree sign here. So 34.5 plus B is equal to 90. I subtract the 34.5 from both sides, and I get B is equal to 55.5 degrees. So that would be the final step to solving this right triangle. So we know the triangle is going to look like, the angle there is 34.5 degrees. The angle up here is 55.5 degrees. We were given the hypotenuse of 12.7. We know that this side is 10.5, and this side is 7.19. So that's how we solve when we are given an angle and a side. In the next video, we're going to take a look at just being given two sides, not an angle.